yesterday, or whenever we did this, we learned about something about an atom, the proton, neutrons, nucleus, and electrons. Protons are positive, electrons are negative, neutrons are neutral. The nucleus holds the protons and neutrons. Protons and neutrons are basically the whole weight of the atom. The atomic number is the same thing as the protons. If there's two protons, the atomic number is 2 onward. The atomic mass number is the number of protons and neutrons added together, since electrons have like no weight. And isotopes, they're atoms of the same element. They have different neutrons. So you could have oxygen has 8 protons because its atomic number is 8. But then it can have 8 neutrons. It can have 12 neutrons. It can have 13 neutrons. It can have 7 neutrons. All those are isotopes of oxygen. An ion is formed when the atom gains or loses an electron. So when it becomes a charged particle, if it gains electron, that means that it has more electrons than protons. If you have more negatives than positive, that means it's a negatively charged ion. If you lose an electron, that means that you have more positives than negatives, and that means that you have a positively charged electron. So we're going to talk a little bit more about the atomic mass of an element. The atomic mass is the average of all of its isotopes. Remember, an isotope has different number of neutrons. It always has the same number of protons because it would be a different element. If you try to change the protons, you're making a new element, and you can't do that. You can have different number of neutrons, but you cannot have different number of protons. So the atomic mass, especially the atomic mass that we see on the periodic table, excuse me, um, periodic table, let's insert a picture. There it is. So these atomic masses right here, this 51, this 54, this 9.012, these are the average of all the isotopes. So they take all the isotopes they find, they average them out, and there's an average of a little over 9 as the atomic mass. So if you know you have 4 protons, how many neutrons do you have? No, 5. You have 5 neutrons because protons plus neutrons equals atomic mass. We know the protons is 4. We know the atomic mass is 9. 9 minus 4 is 5. Okay, let's look at this. Okay, you see that the atomic number for oxygen is 8. Let me write on this so you guys can actually see where I'm at. Yeah, right there, 8. That's the atomic number for oxygen. What does that tell us? It tells us how many protons. How many protons do we have? 8. It also says that the atomic mass of the element oxygen is 15.99, so almost 16. This tells us that the average of all the isotopes for oxygen has about 8 neutrons. 8 protons plus 8 neutrons equals 16. And that's what that is about. So on average, it's going to have 8 neutrons. Now, it depends which isotope we pick out of the air, what the number of neutrons are. We don't know until we look at it. But on average, there'll be 8 protons, 8 neutrons, which gives you an atomic mass of 16. Okay? So again, protons plus neutrons equals atomic mass. We know the protons because we just look at the atomic number. We know the atomic mass, so we can figure out the number of neutrons. All right, so again, that's atomic mass, and that's how we get protons, neutrons, and electrons. All right, the periodic table, which this is the periodic table. This was started by Mendelov, Dmitry Mendelov, Russian, blah blah. Who cares where he's from? The big thing is that he started it. And when he started, you can look on page 18 of your book. That was his original work that started to be um, the periodic table. And you can see that he's got them grouped, and that he even has question marks. He knows that something goes there, but he doesn't know what. And he's got the atomic masses. Um, See, he has beryllium. Be has 9 as atomic mass, and with all the technology we have, it's 9.0122. That's pretty impressive. Boron, he has as 11. It's 10.8. So back then, when he couldn't even see him, doesn't know anything about it, starting the whole thing off. This is how he came about. That's impressive. All right, so the periodic table. It is made of a bunch of rectangles. In these rectangles, they will have an atomic number, which is the top metal, middle, M-I-D-D-L-E. And this one is hydrogen, number 1, the element number 1. Underneath that will be its symbol, which for hydrogen is H. And underneath that will be its atomic mass. You never realize how hard it is to write with one of these until you try to do it. That's an 8, by the way. Okay, so this is the periodic table. This is a periodic table is made up with a bunch of these rectangles. Element number 1, the element's name is hydrogen, and it has 1.008, or basically 1 as its atomic number. So that tells you how many neutrons does it have? Correct, 0. Hydrogen has, on average, 0. Very few of them have 1, but on average, they have 0. Also, on a lot of them nowadays, they have the element name written underneath this, which I'm not even going to try to do all of it because it'll never happen. So we're going to do hydro, and that's pretty darn good. You could read it. And you can see on the periodic table that we downloaded, it doesn't have the name. So after you use a lot, you'll know hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, blah, 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 blah. You'll get to know the names of them once you start working with them in chemistry a lot. But in some of them, they actually write the name underneath it. And that's good, just because I know some teachers will make you memorize the first 50. I know in Tuscola, they made Rachel memorize the first 50. Of course, that's cesium. It's like one of the 7 doors, number 50. Isn't that funny? But what point is memorizing them? Anywhere you go that you're going to need them, you will be able to find a periodic table. If you need one, you'll be able to find them. So I'm not going to make you memorize what they are. I'm just going to have you try to um, know how to get the information out of them, like 6 carbon or C, and it's got a 12.0011 atomic mass. On page 20 and 21 of your book is a periodic table that actually is laid out with the name underneath. So that could become your friends. In the back of the book, you also have a periodic table. All right. You can see, yeah, I'll leave it black. You can see thicker line. You can see that these columns are labeled 1A, 2A, 3B, 4B, blah, blah, 3A, 4A, 5A. Excuse me. So you can see that they're columns. These columns are called groups or families. And they'll talk about family 2A or group 7A. And that's referring to everything in this specific column. Group 8A, these are noble gases. So they refer to these as a groups or families. And it's because they behave the same, very similar. Um, it's like a real family. When you, a lot of times, you'll meet the mom or dad and you can tell the kids because they behave very similar. Um, so these columns are called families or groups, and they are grouped that way because they behave very similar. Like all these, and I'll tell you why in a little bit. I think that's the next section. But for now, all you need to know is family or group. Now, these across these horizontal rows, these are called periods. So all these rows are called periods. That was a nice straight line. And there's certain reasons why those are that way also. Get rid of this so we can actually see them again. Who keeps writing on my periodic table? Stop it, Adam. All right. Now, as we go from this way to this way on the periodic table, the atomic size decreases. But wait a minute. Wait a minute. Right here you have 3 protons, but over here you have 10. Why would it decrease? You have more of them, right? More of the protons, more of the stuff on the inside. Well, as you get more protons, you get more positive charge. Yes, you get more electrons too, but these positive charge are they're stronger, so they're pulling in more tightly the electrons. So that makes the atom actually shrink, makes it smaller. So as you go from left to right on the periodic table, the atomic size shrinks. As you go from top to the bottom on the periodic table, the atomic size increases. And why is that? Because here you have 1 proton, here you have 87. That means that you've got a lot of different rings. You have more electron clouds. They go out farther and farther, and you'll learn more of that as we go. Okay, so this is chapter 1, section 2. We talked about atomic mass, and we really got into the periodic table and the ins and outs, what each of these represent, the 4, the Be, the 9, the atomic name, the atomic mass. We talked about Dmitry Mendeleev. Um, we've talked about groups, which are the columns, periods, which go across. We talked atomic size, shrinks as it goes to the right, but gets larger as it goes top to bottom. And that's pretty much it for section 2. We'll go onward and upward.